Hey everyone, so last time we talked about municipal solid waste, what it is, different kinds of recycling. Now I want to talk to you more about how municipal solid waste is stored, where we put it, what we do with it. And the first mechanism for disposing of solid waste is using landfills. So most of you probably know that in landfills, waste is put onto the ground and then covered up with earth. That's the essential components of a landfill. And we do this because we don't want to just leave trash just scattered all over the earth, because then it will get spread around and can lead to being really smelly, and we'd probably get a lot of rodents going through it. So keeping the air pollution and vermin populations down and avoiding the spreading of the waste like you can see in this picture. When these landfills are eventually capped, a lot of them actually end up becoming public parks. So there's a capped landfill in Virginia Beach that's now called Mount Trashmore. A lot of people go here to play, and I actually used to go here and run, so they can actually become public parks later on once they're capped and sealed off. So there's a bunch of different problems with landfills that I want to talk about first, and then sort of how we've moved away from these problems and improved our landfills. And if you need to pause the video to take some notes, feel free to do that. So one problem with landfills is the generation of leachate. So we talked about leaching, right, where water goes through materials, and then those chemicals in the material, like we talked about it in soil, will dissolve into the water and then are carried away. This can also happen in landfills. So if water is able to get into the landfill, stuff that's in the landfill can start to dissolve with that water. So then you get all these pollutants being dissolved into the water, and that makes up this stuff called leachate. If that leachate is somehow able to leave the landfill, then there's a possibility that the leachate can actually get into groundwater and contaminate the groundwater. Or even surface water, like in Florida. Florida's really flat. There's lots of wetland. The water table, so where the water is higher up relative to the land around it. So it would be easy for leachate in landfills to kind of leak into that surrounding water. So you don't want leachate generation, because then you get groundwater contamination with that leachate. Another possible problem is methane production. So with municipal solid waste, a bunch of the waste is organic material, about 2/3. And when it's decomposing in this sealed off landfill, it's happening in an anaerobic environment, so without oxygen. When stuff decomposes in an anaerobic environment, it produces these byproduct biogases. And one of those biogases, about 2/3 of that biogas, is methane. So methane is highly flammable. So if it accumulates and is somehow ignited, it could actually lead to explosions. It can also seep to the surface and kill vegetations. It's a really potent greenhouse gas, so if it leaks out, it causes those kinds of problems. There are ways to collect it and exploit it and use it as fuel, so we'll talk about that kind of next. Another possible problem is incomplete decomposition. So plastics are going to resist natural decomposition. Plastics are made up of these polymers of petroleum-based compounds. So actually plastics are made of like oil-based compounds, and microbes are not able to digest these polymers. There are biodegradable plastics where the polymers, instead of being made from petroleum-based compounds, they're made from cornstarch, cellulose, soybean, ocean shells, but currently those kinds of biodegradable plastics are much more expensive. So with this incomplete decomposition, you get really slow degradation of materials. More water faster will result in faster biodegrading, but more water also results in a greater amount of leachate. But actually in a landfill, you don't necessarily want decomposition, because if you have this mound of trash and it's been capped off, sealed off, and then now all of a sudden things are decomposing in the landfill, the those things that are decomposing will start to shrink in size, and then the landfill can sort of actually collapse in on itself. So as waste decomposes, it settles and it compacts, and then the landfill can start to sort of cave in, which can result in cracks in that sealed cap. So things that decompose in landfills can actually cause problems for settling. So you almost don't want things to decompose. So here's just how long does it take for trash to decompose. Right, organic materials are going to put like this apple core are going to just decompose much faster. Things that are made of these polymer plastics are going to be decomposed much more slowly. All right, glass takes a really, really, really long time to decompose. Here's something that would be made of like a biodegradable plastic. So here's a plastic bag, and it's been made of one of these biodegradable plastics where the polymer is coming from cornstarch, cellulose, or soybean, or something else, and it can biodegrade fairly quickly. One last thing with this too is that most landfills aren't actually getting what's needed for decomposition. Like you need air, you need moisture, you need organic material. So if the landfill is not getting what it needs for decomposition, it should remain approximately the same size. And in general, you want it to remain the same size because then it's not going to start to cave in on itself. All right, so there's a bunch of ways that landfills have been improved in order to address a lot of these problems. All right, so these would be more sanitary landfills, have these kinds of characteristics. So the first is to put the landfill up on high ground. So you want the landfill above the water table because you don't want any surface water able to seep into the landfill. Like if there was a little bit of flooding and you put your landfill in the floodplain, then you have the potential that water can seep into the landfill and cause some problems. You also want it to drain really well. Another characteristic would be to have a contoured floor. So contoured floor, the floor of the landfill will slope downwards. That way, if any water is able to seep into the landfill, it's all collected at the bottom in the same place. It sort of falls down the sides and will be collected at the bottom. And then at the bottom of that contoured area, you should have a leachate collection system. All right, so here's our leachate collection. So you have this contoured floor, and then at the bottom of that contoured floor, you're able to collect any leachate in these pipes you can see right here, any leachate that is created. All right, and then you can take that collected leachate and treat it. And with this contoured floor, you want the floor and the sides to be covered with clay or a plastic liner. So you want something that water is not going to be able to permeate. It's going to be stopped. So you have clay or a plastic liner that the water will sort of just run off. Now, this refuse layers, landfills are organized in this sort of pyramid type shape that you can sort of see taking place here. And you want to do that pyramid shape rather than just this kind of square box, because you want if any water does hit the landfill, you want it to run off the sides. You don't want it to be able to collect on top of the landfill. If it's able to pool and collect on top of the landfill, then there's potential for that water to eventually seep into the landfill, and then water seeping into the landfill will result in decomposition and then this leachate generation. And typically these refuse layers, this pyramid-shaped refuse layers, will be capped off with about 18 inches of earth, and you get this layer of topsoil then put on, which is then seeded so you can get these nice parks that will grow on top. You don't want to have big vegetation like trees growing on top of these landfills because the roots will crack the cap, but you can have little grass and stuff like that. And that cap is going to be installed once the landfill reaches its capacity. Right? But it's sort of capped off in layers. So you can see here you have a bunch of trash that's been put in here, and then it's been capped off a little bit, right, to contain that trash. And then you have another layer that gets added, and it gets capped off, and another layer that gets added. So it's laid down in layers. So not only do you have this leachate collection system at the bottom of this contoured area. But you also want to make, even though you have this leachate collection system, you want to make double sure that no leachate is entering the groundwater. Because if the groundwater becomes contaminated, that can cause big problems because these aquifers are often pretty large and it would be hard to clean them out. So you also want to put in these groundwater monitoring wells, which you can see right here, and that groundwater monitoring well will reach down into the groundwater and it will periodically sample the groundwater for different levels of contaminants. One thing that can be really difficult with creating a landfill is finding a place to put it, so siting the landfill. No one wants to really live nearby a landfill because sometimes before they're capped off, they can smell a little bit bad, right? So siting landfills can be a bit of a challenge. Stuff that's really okay for a landfill are composite materials, like plastic and paper that are difficult to recycle, glass and plastic, a lot of stuff that's like chemically inert. It won't, if it interacts with water, it's not going to dissolve and create really harmful substances. Stuff that shouldn't go in a landfill includes a lot of heavy metals, right? So you don't want heavy metals in a landfill because they can contribute greatly to leaching. Those heavy metals can start to kind of dissolve, and you don't want batteries in there because the components in the batteries can start to leach out and be pretty toxic. Obviously, you don't want toxic materials. Hazardous kinds of materials are treated differently than these standard landfills. And it's not great to have organic materials in landfills. Much better to compost them because those organic materials can decompose in an anaerobic environment, which creates methane, and then this settling problem. That methane can be collected and then burned, but it's difficult to do. Better to just not have it in the first place. Oh, there's Mount Trashmore again. So landfills are one way to deal with municipal solid waste. Another way to deal with municipal solid waste is through incineration, right? So incineration would be where you actually would burn the trash, and then some of that trash that gets burned will end up in a landfill at some point, but it's burned first, and this burning of waste materials helps reduce their volume and mass. So if you burn trash before you send it into a landfill, then you can drastically reduce the weight and the volume of the trash. You can reduce the weight by 75%, and you can reduce the volume by 90%. So you can fit a lot more trash in a landfill if it's been burned first. So you still need the landfill, but the landfill will last much longer. Its life will be extended. So about 3/4 of municipal solid waste is easily combustible. Stuff that can be combustible includes paper, plastic, food, yard waste, right? And then when you burn these materials in this incineration process, you can actually use that heat to generate heat and electricity. You can use that burning process to generate heat and electricity. So whenever you burn something, you're going to create some ash. So ash is this residual non-organic material that does not combust during the incineration process. And with incineration, there's two kinds of ash that are created: fly ash and bottom ash. So fly ash kind of sounds like what it is. It's suspended up in the air. So it's combustion gases, toxic substances, right? And it's going to collect over this furnace. So you can see here's your waste. Crane picks it up, sticks it in the boiler, right? And that boiler is burning the trash, and then you get fly ash is going to be suspended above that boiler. It's suspended up in the air. Bottom ash is residue that collects underneath the furnace. It's going to collect down here. Bottom ash is similar to like what you would see in your fire pit after you've had some s'mores or something like that. This bottom ash is then often used to fill in construction or road beds. You can use it to create cement, so it can sort of be recycled and you can see it. Here's another picture over here that bottom ash is being shipped away for recycling to make cement blocks and stuff like that. The disposal of the ash kind of depends on the concentration of toxic metals. So if it's low in contaminants, so if the metals have been removed, like lead and cadmium are not present, then that bottom ash can be taken to a landfill or can be recycled. If the ash has heavy metals present, right, so often the ash is processed beforehand to remove the heavy metals, but if that bottom ash is toxic, right, or that fly ash is toxic, then that toxic ash, right, with heavy metals in it is going to have to go to a landfill that's designated for toxic substances, which we'll talk about when we talk about hazardous waste. So to just kind of, this looks complicated, but not so complicated. Waste comes in, crane grabs the waste, dumps it into the boiler, right? You get that suspended fly ash up here, and then you get that bottom ash that settles out below the boiler. So whenever you're heating something, right, if you're heating something and there's some pipes with water, so here you can see some pipes with water going through the boiler, that water will boil, right, and then that boiling of the water creates steam. So that steam that's created from the burning of the substances can then travel through this turbine generator, and what it's doing is the pressure from the steam is turning something, and then this turbine, and then that turning of the turbine can generate electricity, which is then transferred to the electrical grid, right? So burning the trash produces this, is allowing for this steam turbine generator to produce electricity, right? And then this fly ash is going to go through this filtration system, right, so that the fly ash is captured, and then that captured fly ash will be sent to a landfill, right, and you have a bunch of controls and tests, air quality tests, and what's left over should actually just be steam, should be just water vapor. So when you see an incineration plant, that smoke that's coming out of the incineration plant is just steam, because that fly ash should have been largely removed from that. Right? One kind of advantage, or you could maybe say a disadvantage, to having incineration is that it requires no change in behavior. Since it reduces the trash by volume and weight so much, you just take it to the combustion facility and you get rid of it. So it doesn't require us to reduce as much how much waste we're producing. Another advantage, obviously, for incineration is this whole waste to energy piece, right? You can use waste, you can use the burning of waste to create energy. And it creates 35% as much energy as coal, pound for pound. So it creates quite a bit of energy. Right, here's just another picture of this incineration process. Right, so waste is coming in, inspection station, shredding that down the waste so it fits through the tube, and then a magnet can actually sort out some of the metals, and then those metals can be handled differently, right, so they're not contaminating the ash. And then all that waste gets put into the boiler, right, gets burned, fly ash is created, and it's suspended up here. You have water passing through the boiler, so then the heat is causing that to create steam. Then that steam comes down through here, turns a turbine generator, and then that generates electricity. The bottom ash is going to, if it's not toxic, it'll be sent for recycling or sent to a landfill. And then that fly ash is going to get treated, right? It's going to get filtered out, and then what's left is just steam. So some problems with combustion. There is some degree of air pollution, right? They filter out most of the fly ash, but some could escape. So there's pretty high air pollution regulations now. So it's really much lesser problem now because of those stringent air pollution regulations. But there's still a possibility that maybe some could escape. It also might smell kind of bad. Right, so you have to isolate the plant. You don't want this in a place where a lot of people live. These incineration plants are pretty expensive to build. No one really wants to live nearby. The tipping fees, so tipping fee is how much it costs to drop off the waste. Tipping fees for incineration plants are much more expensive than landfills. So much cheaper to tip waste into a landfill than to tip waste into an incinerator. Another possible problem is the ash, right? If the ash contains metals and hazardous substances, then you need to find secure landfills, hazardous waste landfills to put them. Another possible disadvantage to incineration is that this sort of promotes waste production. The plant is not going to be able to run without municipal solid waste, so it needs a continuous supply of municipal solid waste. So you don't want to promote waste reduction, because then you're not going to have anything to burn, and then you can't do this whole waste to energy piece. So sometimes this actually ends up competing with recycling for burnable materials. So just a few pieces of public policy that you guys are going to have to know. The first is the Solid Waste Disposal Act of 1965. This gave jurisdiction of solid waste to the EPA. So the EPA is what is the government agency that is now handling solid waste disposal. The Resource Recovery Act of 1970 started directing attention to recycling programs. So this gave jurisdiction of solid waste to EPA. This Resource Recovery Act started creating these recycling programs. This Resource Conservation and Recovery Act, so RCRA, of 1976 actually started closing local dumps. So local dumps, just places that people would just have, trash just dumped onto the land. And this actually was where you started to see regulations for landfills. So you started to see the creation of these more sanitary landfills that had, leachate collection systems and groundwater monitoring systems that were much more stringent. This last one is the Superfund Act in 1980, and we're going to talk more about this one when we do hazardous waste. But this started to address abandoned hazardous waste sites. So trying to identify and clean up hazardous waste sites. Right, and that's it. There's this little video if you guys are interested, just on, it's called I think Perfect Plastics. Just these people allow you to create these do-it-yourself machines so you can recycle at home, where you can grind plastic down and then reuse it. So they can grind these plastics down. All right, so you build the machine. Precious plastic, sorry. And then you can extrude the plastic into these filaments, and you can actually use it for 3D printers, which is pretty neat.
Precious Plastic runs fully on the power of the community. We started working on providing people the tools and knowledge so they can start recycling plastic themselves.
Pretty cool. All right, let me get out of this. All right, so that's all I have. So now your task is to think about, what makes a sanitary landfill, and then based on materials that I'm going to give you in class, the next block, you guys are going to create, little miniature landfills. So the kinds of materials you'll have available will be clay, gravel, sand, popsicle sticks, some toothpicks. Trying to think what else. The trash is going to be cotton balls that are soaked in food coloring. And we're going to test your landfills with earthquakes and wind and water and see how they do. See if there's any leaking. All right, thanks guys.